Welcome to another exciting additional video brought to you by Vision Concepts Academy. So today we're looking at past WAEC math question on sequence and series. What we're doing in this series is to look at different topics and solve every likely questions, every pattern of past WAEC questions on that particular topic. So today we are X-ray sequence and series. So sit tight and enjoy this video. If you're here to subscribe to our channel, kindly subscribe to our channel to get the best from Vision Concepts Academy. So we dive in. The first question we have here is on arithmetic progression, and it says find the nth term of an AP. AP stands for arithmetic progression. So the 10th term, and you are given this progression 2, 5, 8, 10, and so on. So one of the things to do to know whether a progression is an arithmetic progression is to check the common difference between the preceding terms. This is known as the first term, this is known as the second term, this is known as the third term, and this is known as the fourth term. This dotted sign shows that it's continuous. It can be endless. The terms continue. So between first and second term, difference between the two of them for this particular series is 3, because 5 minus 2 is 3. The difference between 5 and 8 for this particular term is 3 as well, because 8 minus 5 is 3. And the difference between 8 and 11 is also 3. Note that this difference is common. They are all 3, 3, 3. So to find the nth term, T10, T subscript 10, of this particular kinds of series known as the AP, arithmetic progression, the formula is A plus open bracket n minus 1, then d, where a is the first term, n is the number of terms, so d is the common difference. I'll define common difference as the difference between the term and the preceding term in the sequence, right? Common difference, if I can spell this. Okay, so looking at what we have here, to find the 10th term, so T10, T subscript 10, that's the 10th term, is equals to A plus open bracket n minus 1, then close bracket d. Particular sequence, A is 2, n is 10, and d is 3. So T10 is equals to A is 2, that's 2, plus open bracket, n is 10 minus 1, then close bracket, then 3, right? Okay, so we have it as 2 plus 10 minus 1 is 9 times 3. So 9 times 3 is 27. 27 plus 2 is equals to 29. So the 10th term is 29. So that if you continue this sequence and writing, when you come to the 10th position, 29 will be there. So that's the answer. So here, it owes you to know the formula, understand the concepts of the terms. The terms are actually the positions of the sequence. So the first number in the sequence occupies the first term. The second number in the sequence occupies the second term, and so on and so forth. Okay, so know the formula and know how to find the number of term. Okay, so the next question is still on arithmetic progression, and this is the sum of terms. It says find the sum of the first 20 terms of. So again, we are given 7, 10, 13, and continuous. So those sign shows that the series is continuous, right? There are numbers there. So for sum of terms Sn is given as n over 2 open bracket 2a plus n minus 1 then close bracket d. This is the summation. This is the formula for the sum of term. Okay, so the subscript n in this s n is the number of terms. So n is number of 10, and the a is the first term, n is the number of term, and d is the common difference. So for this particular sequence, we are told to find the sum of the first 20 terms, right? So it is n, that is 20, over 2, in bracket 2 times a is 7 in this case, plus n is 20 minus 1. Then common difference is the difference between the two terms. 7, 10 and 7. Difference is 3. And 10 and 13 difference is 3. So it's common. 3 is common. So 3 is the common difference. So 2 here, 1, 2 here, 10. So 10 is outside. Then 2 times 7 is 14. 14 plus, then 20 minus 1 here is 19. That's 19. Then times 3. Okay. So at this point, we'll do 19 times 3, then plus 14, and multiply by 10. Okay. So by way of calculation, 19 times 3 will give us 57 plus 14. 57 plus 14 will give us 71. 10 is still outside. 10, then 57 plus 14 will give us 71. And 71 times 10 will give us 7710. 710 is the sum of the first 20 terms of this sequence. 710 is the answer. So again, master the formula for sum of terms of an AP and put in the formula, then you will get the answer. Okay, so the next question is still on arithmetic progression. Now we are asked to find the missing term. Find the missing term. So say find the term of the AP 20, 16, 12 that equals minus 20. That equals minus 20. So in this case, we are finding the term, the nth term, understand, that equals minus. So t subscript n is equals to minus 20. What is that term? What is n? What is that term? Recall that number of term Tn is equals to a plus open bracket n minus 1, then close bracket d, right? Where a is the first term, n is the number of term, d is the common difference. From this sequence, what is the common difference? You see that the difference between the first and second term is minus 4. Now note, when you are getting the difference, you are subtracting the lower term from the upper term, right? So the lower term, this is first term, that's 1, second term 2, third term 3. So the lower term here for the first term is is 20. So the difference is 16 minus 20. 16 minus 20 will give us minus 4, and 12 minus 16 will give us minus 4. So the common difference is minus 4 for this particular formula. So we are asked to find the term, the nth term. So it is n we're looking for, actually, n we're looking for. And we know that that nth term is minus 20, right? So I'm going to form an equation here where the minus 20 is equals to a, first term is 20, plus n is unknown, minus 1, but d is given as minus 4. So we have written the arithmetic, the formula. Every other thing is just algebraic expressions. That's to solve for n, algebraic equations, solve for n, right? All right. So at this point, I will just say minus 20 here equals to 20 here. Then open the brackets. Minus 4 times minus 4 outside here times n is minus 4n. Minus 4 times 1 is plus 1 plus 4. Sorry. Okay, so I will take every constant term to this side of the equation. Take every constant to this side of the equation. So if minus 20, if 20 goes here, becomes this minus 20 is here. Then this one we join to be minus 20. This one we join to be minus 4 is equals to minus 4. So what I've done is to correct items. So minus 20 is minus 40. Minus 40 minus 4 is minus 44. It's equals to minus 4n, right? So this minus, we cancel this minus, right? So I have that 44 equals to 40, sorry, 4n. Divide both sides by 4. So I have 4n, 44 over 4 is equals to n. So 4 cancels and I have 11. N is 11. So 11th term is where we have minus 20. That's what this interprets to be. That interpretation. That the 11th term, that is where we have minus 20. So if we continue this sequence like this, let's see. Let me take this off. If we continue this sequence like this, continue from 20 to 16, 12. The next one is 8, right? 8. The next one is 4. Next one is 0, minus 4, minus 8, minus 8, minus 12, minus 16, minus 20. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 11th term is the minus 20. That's what the question is talking about. It behoves us to understand what we need to get and apply the formulas. Okay, so there are fundamental formulas we need to know, like the number of terms, the sum of terms, then know the parameters involved, hence term, common difference, and the number of terms. So this is the answer simply. Number 4, it says that the arithmetic progression, the fifth term of this sequence, 2, 5, 8, and so on. What's the fifth term? T5, T5, T subscript 5 is equals to A plus N minus 1, then D outside, right? So the fifth term, A here is 2, then plus N is 5, that's the fifth term, minus 1, then D is 5 minus 2 is 3, right? And see 5 minus 8 minus 5 is 3. So the common difference is 3. All right. So you can just get this sum of this. 2 plus 5 minus 1 is 4, then times 3. 4 times 3 is 12 plus 2 is equals to 14. So 14 is the fifth term of this particular progression. Okay, so now we are going into geometric progression. For geometric progression, the nth term is equals to a r n minus 1 raised to the power. So this is the formula for geometric progression. How do you know a progression is geometric? The difference between this and this is you look at the preceding terms. If you divide the preceding term by the succeeding term, all right, no, the succeeding term by the preceding term, you will get a constant number. How do I mean? Let's inspect what we are given. We are given 2, 6, 18, and so on, right? So this is the succeeding term to this preceding term. The succeeding term, the next term. The preceding term is the previous term, right? Succeeding term 6 minus over 2. Succeeding term 6 over preceding term 2. If I get the division is 3, here 1, 2 here 3, right? Again, I move from here to here. The succeeding term is 18, preceding term is 6. If I say 6 here 1, then 6 here 3, you see that I'm getting a constant value. This constant value that I got by dividing succeeding term by preceding term is known as the common ratio. is known as the common ratio. So the common ratio is the division of the succeeding term by the preceding term. It must give me a constant number even as I inspect in the particular series or sequence. So for this particular question, we're asked to find the fourth term. Actually, we have 2, 6, and the 2, 6, 18. Then the next one will be the third term, the fourth term, right? So let's apply this formula that we have now to get that fourth term, and also use our test to know whether succeeding and proceeding will give us a particular number. Okay, so again, the first term for this sequence is 2, which is A, times R common ratio, which is 3. We're getting it from here. A times 3 raised to the power n is 4 raised to the power 4 minus 1. All right, so T 4. We're looking at the fourth term. So T sub 4 is equals to 2 times 3 raised to the power 4 minus 1 of the power is 3. So 3 raised to the power 3 is 3 times 3, 9. 9 times 3, 27. So 27 times 2 will give us 54. So 54 is the fourth term of this geometric progression, the fourth term. So if I put 54 here, if I do the test of this divided by this, will it give me 3? 54 over 18. Okay, so let's go. 54 divided by 18. 54 divided by 18. I'm punching my calculator. That will give me 3. So this is correct. So the fourth term is 54. Okay, so we have to find the sum of the first 5 terms of this geometric progression. So the sum of the first 5 terms is given as this. This is the formula for the sum of the first 5 terms. And then we know that the first term A is A. Common ratio is 2. Why? Because 6 divided by 3 is 2. And 6 divided by 6 is 2. So it's a common ratio. The number of terms is 5, right? So this formula is 5. Sum of terms equals to A raised to the power, open bracket, R n raised to the power n minus 1, then all over R minus 1, right? So A is giving us 3, putting oblique brackets, then R is 2 raised to the power, and n is 5, right? N is 5, then minus 1, all over 2 minus 1. So when we go to this point, you can say 3 open big brackets, power 5 is 32 minus 1 over 1, because 2 minus 1 is 1, right? So I have 3 open brackets, 81, because 32 minus 1 is 31. By the time you multiply this, I'm getting 93. So that is the final answer. Sum of the first 5 terms of a GP. GP means geometric progression. All right. So it says find the second term. Sorry, if the second term is 12 and fifth term is 96, find A and R. Okay, so this is the term T2 second term A R raised to the power n minus 1. So if this one is 12 and T5 is A R n raised to the power minus 1, the power n minus 1 is 96. Find A and R. Find A and R. Okay, so we are given to so this translates to this. This one translates to this. This is for the this is for the second term, right? This one translates to this, and this one for the fifth term translates to this, right? So we can actually divide the two equations. Okay, so A raised to the power 8 r raised to the power 4 is equal to 96 over A r is equal to 12, right? So this and this will cancel. Then I can get this divided by this is r raised to the power 3 equals to uh, 8, and r will give us 2. Why? Because if I this r raised to the power 3 equals to 8 means that 2 to the power 3 will give us 8, right? So the r is 2. The r is 2. Compare this one and this one, right? So r is 2. If r is 2, we can substitute any of this equation. Substitute in a, r is equals to 12. So if I get a as r as 2, so a will now be as a times 2 is equals to 12, and a is equals to 12 over 2. Okay, so note how this is done when you see two different progressions, because these are two different progressions. That's instances, not the same progression, but two instances. We're given the second term and we're given the fifth term, instances of the equation. So you know the progression, geometric progression. So you know the formula. When you know the formula, you can divide the bigger term, the bigger formula by the smaller formula. That's what happened here. Here, divide it so I can get one of the term, one of the variable. We're asked to look for a and r, right? So by the time you divide the two of them, we are getting r. When you get r, we can come back and put r in any of this equation, either this or this. Recall that these two are simplified from the original expression, right? Okay, so this is clear. Okay, so we're looking at pattern recognition. So some of these sequences or series have patterns. Though we'll be able to define the patterns by the name of the particular pattern. So for patterns of arithmetic progression, it shows that the preceding term and the succeeding term have a constant difference, which is the common difference. For GP, geometric progression, the pattern is that the succeeding term and the preceding term, if you divide them, you'll be getting a constant, which is common ratio. But sometimes you might not have them called geometric or arithmetic. This one is actually arithmetic, but I want to just you introduce to you pattern recognition. So if you see that this is 3 and this is 7, this is 11, this is, so the pattern actually is that the difference between the preceding term and the succeeding term is that 7 minus 3 is 4, or 11 minus 7 is 4, or 15 minus 15 minus 11 is 4. So the next one is that difference is 4. To get the next one, just add this to this. 4 plus 15, I'll get 19. So this is how you just figure out some things. It might not, the next question might not be, for pattern recognition, might not be as simple as what I have shown us here. I think in the course of this video, we will see some other one that you need to um, decipher the pattern, or what is constant, what is happening. Is it a plus of a particular number? Is it that sometimes it's a mixed pattern? You understand? Once you can get the pattern from the given progression or sequence you are getting, you can now predict, subsequent terms. All right. So another pattern recognition I have for you here is this kind of question. It says find the fifth term if Tn is equals to 3n minus 2. Now, what is happening here is that we are giving a particular formula for that pattern. So all you have to do is to put 5 where you see n, and you get your answer. If, for instance, this same particular formula, and you're asked to find the system, all you have to do is to put 6. 6 is equals to 3 into 6 minus 2. So 3 times 6 is 18 minus 2, which is 16, and so on. If you're asked to find T7, that's 7th term, just put 7 where you have n, 7 minus 2. So 3 times 7 is 21 minus 2, which is 19, and so on and so forth. All right, so number 10, geometric progression. sum to infinity. Find the sum to infinity. So this one, there's a formula for finding the sum of a geometric progression to infinity. So the formula is S is equals to A over 1 minus R. So identify your A. Your A is 16 from here. A is 16 and R is 8 over 16, which will give us 1 over 2, or 8 over 16, sorry, 4 over 8, which will give us 1 over 2, or 2 over 4, which will give us 1 over 2. These are gotten from this divided by this, or this divided by this, or this divided by this. So when we plug in all these parameters in this formula, we're getting 32. Okay, so the third term of an AP is 11 and the seventh term is 23. Find the common difference. Find the common difference. So this is the third term of an AP. AP, third term, T3 AP. AP formula is A plus N minus 1, then D, right? So T3, the third term is what? Third term here is 11 and T7 is 23. A plus N minus 1 D is equals to what? 23. So I have a form of equation like this, where this N for this particular first one is 3. So I can come here, equation 1, I call this one equation 1, and this one is equation 2. So I come here, I say equation 1, A is unknown, but N is known as 3. Why? Because it's the third term I'm looking for. Then D is unknown and 11 is here. Then for second term or second equation, A plus open bracket, and for this particular equation is 7 because it is seventh term, and the D unknown is equals to 11. So sorry, 23. So I have two equations solve simultaneously, right? Let me write them here again. A plus this first term, first equation is 3 minus 1 is 2D is equals to 11. Second equation, A plus 7 minus 1 is equals to 6D is equals to 23. All right. So I have two equations here. So if I do subtraction of this, subtract both sides up and down. So A will cancel A. So 2D minus 6D is minus 4D. And 11 minus 23 will give me minus 12. 11 minus 23 will give me minus 12. So minus 12 is here. So D, common difference is minus 12 over minus 4. And D is equals to 3. So if D is 3, I can put it in equation 1. I can put it in this equation, this one here. So I come here, I say A plus 2 into 3 because D is 3 is equals to 11. So A plus 2 times 3 is 6 is equals to 11. So A is equals to 11 minus 6, which is equals to 5. So I have that A is equals to 5 and D is equals to 11. So I've gotten it. What I've applied here, I've applied the simultaneous equation principle. Maths is interrelated, the topics are interrelated. So if you understand that simultaneous equation principle very well, once you have two equations with same set of variable and they were to find them at the same time, then you can apply simultaneous equation. Okay, so this is the answer. Okay, so number 12 says the fifth term is 18 and the common difference is 3. Find the first term. The fifth term is 18 and the common difference is 3. Find the first term. So this is simple. As you can see it, you see that the fifth term is 18 and the common difference is 3. So if you put 3 here, 3 times 4 will give us 12. So 18 is equals to A plus 12. I can subtract both sides by 12. A will now be equal to 6. Okay, so find the sum of the first 15 terms of A of 4, 7, 10, and so on. This is also AP. You see that the common difference is 3 already. First term is 4, right? So just substitute. A is 4, D is 3, and N is 15. So this is the formula for sum of terms. The formula for sum of terms. Just plug in the values. Where you see A, you put 4. Where you see D, you put 3, and where you see N, you put 15. So the answer is 375. How many terms of the AP? How many terms of the AP 3, 7, 11, and so on are needed to get the sum of 406? How many terms? So we are looking for number of terms, right? So sum of term here, Sn is equals to n over 2, open big brackets, 2a plus n minus 1, close bracket d. So you see that you have sum of the term as 406. So is this n we're looking for? We're looking for n. You have a as 3, you have n still unknown, and d is 4. Why? Because 7 minus 3 is 4, or 11 minus 7 is 4. Anyone. So I take 4, right? So this will give us a simultaneous a quadratic equation, definitely, because I'm going to be getting a square for n. So n over 2, open brackets, 2 times 3 is 6, plus 4 times n is 4n, and 4 times minus 1 is minus 4, right? So I can multiply each term by, okay, let me just do 406 is equals to n over 2. Then this is now, this and this will give me 2 plus 4n, right? So I can actually bring out 2 outside. 406 is equals to n over 2 times 2. I'm doing factorize. I will factorize. What is common in these two terms is 2, right? So what's left inside is 1 plus 2n. So 2 cancels 2. So I have 406 is equals to n, this n, open bracket, 1 plus 2n. And 406 is equals to n times 1 is n, plus n times 2n is 2n squared. So I'm getting 2n squared plus n minus 406 as the quadratic equation. So I'm going to be solving this and we're getting a solution. Just note this. Note this equation I've gotten. Let me take it off. Let me take it off. So the first thing is to try and get the equation. Get the equation. When you get the equation, you put in the parameters. We need to get n. We need to get n, right? So when you put all your parameters, now n will appear as n, that quadratic equation that we have. Okay, so let's go to the printed version. So this is what it turned out. So this is the quadratic equation I showed you on the written on the slide. This is so from here we can use formula method to get n. You're going to be having two solutions. We're taking the solution that is positive. That is positive because you have this solution that has say minus 1 plus 557. This one is positive. The other route is minus 1 minus 57. This one, that route is a no-no for us. So we're taking the first route, minus 1 plus 57. So minus 1 plus 57 is 56 over 4, which will give you 14. So the number of terms in 406 in this that are needed to get a sum of 406 is 14. Find the common ratio if the second term is 6 and the fourth term is 54. Okay, so these are two different instances again, second term and fourth term. So find the common ratio. We have this one like this before, something like this before. So what you do again, second term T2 is equals to AN AR to power n minus 1 is AR. And the sixth term T6 is equals to uh, a r raised to power n minus 1. Okay, now T2, let's put the number of terms. A r, right? Number of them is 2 minus 1. And T6 is a r raised to power 6 minus 1. So for these two instances, um, first one, T2 is a r, because 2 minus 1 is 1, right? And T6 is a r raised to power 5. So at this point, I can divide these two of them. I can come here and say T6 over T2, which is a r raised to power 5 all over a r, right? We are asked to find r. So a will go, uh, okay, so a will go, then r now becomes raised to power 4. But mind you, we're told that T6 is what? T6 is 54. Okay, I've gotten this. I left off somewhere. We are supposed to put this T6. There's a value for T6 and T2. T6 is the value there for T6 is it T6? The ratio of second term is 6 and fourth term. Okay, not is T4. T4. Wow, 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 wow. So I will take this off and start again. I got it mixed up because of the terms I'm getting mixing up. Okay, so let me just do it again. Okay, so take it gradually. So the common ratio, find the common ratio. If the second term, T2, second term is a r n minus 1, and T2, which is what? 6. T2 is 6, right? Then a r, then 2 minus 1. This is one equation. Let me call equation 1, right? Then the other one is T4, not T6. T4, okay, is a r, then 4 minus 1, and T4 is what? 54, right? Is a r, then 4 minus 1 here, the power 4 minus 1 here will give you 3. So this is equation 2. So the two equations, I can divide them. So I can say 5 4, equation 2 is upstairs, is equals to a r raised to power 3. That's equation 2 upstairs. Then all over downstairs is 6. It's 5 4. This is not 5 6, 5 4. 5 4. Okay. Then 6 is equals to a r, right? A cancels a. Then 6 here, 1, 6 here, then 9, right? So r here 1, r here r square. So I have r square is equals to 9. So from here I can get r as 3. That's what is happening here. Okay, so this is just like a breakdown of what I have here in summary. Okay, so the next question is on 16. It says find the sixth term of 5, 10, 20, and so on. This is a GP. This is a GP because 10 divided by 5 is 2 and 20 divided by 10 is 2. It's a GP. So the system is just mainly to put the parameters ar raised to power n minus 1, where n is 6, n minus 1 is 6 minus 1, which is 5. So T6 is a times r raised to power 5, and the r is given as 2 from this question. Then we'll get the final answer, 160. Okay, so find the sum of the first systems of 2, 6, 18, 2, 6, 18, and so on. Sum of them again is given as this formula: S subscript n is equals to a open bracket r raised to power n minus 1 over r minus 1. So we just first of all identify all the parameters. A is the first term, which is 2. R is the common ratio, which is 3. N is the number of terms, which is 6. Plug into this formula, and we're getting 7 to 6. And the sum of GP to infinity, I told you that the formula is S is equals to A over 1 minus R. So for this particular series, A is 9, A 9, and R is 1 over 3 because 3 divided by 9 is 1 over 3, or 1 over 3 is 1 over 3 as well, right? Anyone can use get your common ratio, and we plug into the formula, you'll be getting 13.5. Yes, this is another pattern recognition I like. Now, this pattern recognition is not actually AP or GP. Why? Because 4 minus 3, 4 minus 1 is 3, right? And 9 minus 4 is 5, is 5. And 16 minus 9 is 7. Okay, so there's a pattern here, but another pattern too I can also see is that 1 is 1 square, and 4 is 2 square, and 9 is 3 square, 16 is 4 square. So you see that is going by natural numbers, right? So I can put that the formula here is n square, where n is natural integer number, natural numbers, right? So it means that this is first, one, two, three, fourth term, right? So the fifth term, the next term is 5 raised to the power 2, which is 25. That means the next thing I'm going to see here is 25. So if I want to do the difference between this one and this, what will it give me? Give me 9. Though there's another pattern I'm seeing here. The pattern is that 5 is like 3, 5, 7, 9. Then I think the next one will be 11. 11. So that if I add 11 to 25, I will get the next one. Now let me use my formula to check whether I'll get that one. So the next one should be 1, 2, 3, 4, 5, 6. 6 term. 6 raised to the power 2 will be 36, right? So after 25, I'm expecting 36 here. If I subtract 25 from 36, will it give me 11? Wow, it did. It did. So this difference is progressing by 3, 5, 7, 9, 11. Next difference will be 13, right? 13. So that means if I add 13 to 36, I'll get the next term. But I think this pattern I just brought out in this particular question is better because it's easier to just list the term and put that number. Because why I'm saying that this my pattern is better is that if I'm told to get the 20th term, for instance, I will not go through all this to get the 20th term. I'll just go 20 raised to the power 2, which will give me 400. So 400 is the 20th term in particular series, right? Okay, so the last for this particular video, he said find the next term. This is a mixed pattern recognition. The pattern is mixed. Why? Because you see that 2 and 6. What's difference? Difference is 3. Difference is 4. Okay, difference is 4. This one is 1. Difference is okay, so I cannot use that one. And next thing I can use is that if I multiply the term 2 by 3, to give me 6. And the next one, if I add 1 to it, will give me 7. So I multiply this one by 2, then add this one to 1. Multiply this one by 2, add on to 1. So you see that for me to get this pattern, the first term is 2. If I multiply by 3, I get 6. If I add 1 to 6, I get 7. If I multiply 7 by 3, you understand, I get 12. And if I add 1 to 21, I get 22. So the next one, if I multiply 22 by 3, I get 66. And if I add 166, I get 67, and so on. This is known as pattern alternative. Pattern alternative. All right. So I hope this video has been fruitful for you. I'd like to thank you for viewing. Kindly subscribe to our channel if you're not subscribed to our channel, and stay tuned and stay tight. See you in the next lesson.